Well, hello again, mathletes. We've already gone through the setup on this. So we've already used the zero product property along with factoring to be able to solve an equation. What I want to do today is actually go through and just see some more examples of this. So let's go ahead and get started here. So again, the zero product property is what we're using. And so the idea is to rewrite our polynomial so that it's two or more things being multiplied together. And basically that is factoring. We want to rewrite it as multiplication. So let's go ahead and walk through this, right? We have our zero product property, so we want to rewrite it so that it's two things being multiplied. And then we can take each factor and create a new equation with those. Okay, so the first example I want to walk through here is 2x squared plus 3x minus 2 equals 0. Now remember, one of the conditions here to be able to do this is that you have to have 0 on one side of the equation. And we do have that, so that's our first checkoff. So we don't have to worry about getting a 0 on one side. But we do have to worry about factoring this thing. And in this particular example, the leading coefficient is not a 1, right? If that was a 1, this would be a much shorter process like the last example I did in the previous video. However, that's not a 1, which means we have to go through the entire master product and grouping process. So if I go ahead and draw my magic X here, my master product is 2 times negative 2, so that's a negative 4. And then the sum I want is 3. And I can see that I have negative 4 and 1 as my magic numbers here. Now in this case, we can't jump straight to that double bubble. What we have to do is split up the middle term. And so let me go ahead and erase this. With these two numbers, negative 4 and 1, we can rewrite this as 2x squared minus 4x plus x minus 2. And now that we have four terms, we can split this up. The common factor in my front term would be 2x, and that leaves me with an x minus 2. And in the back end, x minus 2, the only common factor for x minus 2 is 1. So we'll go ahead and put a plus 1 here. And that leaves me with an x minus 2. And now x minus 2 is my common factor, so I can pull that out. And that leaves me with x minus 2 times 2x plus 1 is equal to 0. Now that exactly fits the condition that we're looking for. I have two things being multiplied to give me 0. And so what I'm going to do here is separate those into two equations. I get x minus 2 equals 0, or 2x plus 1 equals 0. And so at this point, I'm just going to solve these. If I add 2 to both sides here, I end up with x is equal to 2. Here, I'll go ahead and subtract the 1 from both sides, so that gives me 2x is equal to negative 1, and then divide by 2 to give me x is equal to negative 1/2. And so those are my two solutions here. So x equals negative 1/2 or 2. Right? Now, it usually comes up at some point. Someone asks me if I have to write them in this particular order, right? They have to put negative 2 first and then 2, or if 2 can come first. And it actually doesn't matter which order you write them in. It's just kind of typical, especially when you're looking in the answer key of a book or anything like that, for them to be written from smallest to biggest, but there's no law about it. All right. So that's our first example there. So let's go ahead and erase that one, and we'll look at our next example. All right. So our next example looks like this. We have x times x plus 3 equals 4. Now, we got a couple of problems here. This thing doesn't look anything like the stuff that we've been working on here. I do have two things multiplied on the left-hand side, but I don't have them set equal to 0, right? And so what I need to do at this point, if I don't have a 0 on this side, on the right-hand side, or whichever side you choose to put your 0 on, what you're going to need to do is move things around so that you can get a polynomial equal to 0. And so that's what I'm going to do. I'm going to start by distributing this. This gives me x squared plus 3x equals 4. Now, I still have a problem. This thing is not set equal to 0. And so I need to get one side equal to 0. And I think in this case, because there's a single number there, the right-hand side would be the easier one to make a 0. And so what we're going to do here is subtract 4 from both sides and rewrite the entire thing as x squared plus 3x minus 4 equals 0. Now, looking at this, in fact, I'm going to rewrite it over here. This is much more like the original problems that we've been seeing. So we had to massage this thing a little bit to get it into the form we wanted. So I'm just going to rewrite the problem here. So we got x squared plus 3x minus 4 equals 0. And so that means we have a 0 on one side. And now what we need to do is factor the other side. Now, in this case, we have a 1 as our leading coefficient. And that's really nice to have, because what that means is that whatever numbers we have in our magic x are the ones we can put directly into our double bubble. So the master product is 1 times -4, so that gives me -4. And the sum I want is 3, and so that leaves me with a 4 and a -1 here. And because this is a 1, because we have a leading coefficient of 1 here, I can just I can take these, the 4 and the -1, and just write them in here. X minus 4, x plus 1 equals 0. And then I have two equations to solve. I have x minus 4 equals 0, or x plus 1 equals 0. And here, if I add 4 to the other side, I get x is equal to 4. Here, if I subtract 1 to the other side, I get x is equal to -1. And so we have our two solutions. X is equal to -1, 4. And that ends up being my final solution. Okay, so now I want to go ahead and look at our next example. All right, so the next one looks a little more complicated. One of the things you want to remember is that really most of the time, not always, but most of the time, the form you end up with ends up looking like this. But it's not going to be 100% of the time. But definitely keep that in mind, that most of the time this is a goal. Definitely the 0 on the right-hand side is a goal. Okay, so let's look at the next one here. So this one we have 3x squared minus 5x plus 2 is equal to x squared minus 1. Now, the left-hand side looks like the type of thing that we want to get a hold of, but it's not equal to 0, right? And that's our big problem. We need to have a 0 on one side of this, or else I cannot use the 0 product property. And so what we need to do is pick a side here and 0 it out by subtracting everything that's on this side to the other side. And so I'm going to choose to do this with the right-hand side. So if I subtract x squared from both sides, what that's going to give me now is 2x squared minus 5x plus 2 is equal to -1. And that's still a problem because the right-hand side is not a 0. So I'm going to add 1 to both sides. That'll 0 out the right-hand side, and I'll have a proper polynomial on the left-hand side. Okay, now, this is the form we're trying to get, right? It's that ax squared plus bx plus c equals 0. right? It's this guy up here. So we need to factor this left-hand side. And so I don't have a leading coefficient of 1 this time, so that means I have to go through the grouping process. And let's see here. I'm going to rewrite the polynomial over here. Right, and we'll go ahead and put our x here. So let's see, what does this x entail? We have 2 times 3 is 6, and -5 is our sum. Now, 6 is a positive number, which means I'm either multiplying 2 positives or 2 negatives. Their sum is negative, which means both of them in this case have to be negative, or else I'm not going to get a negative sum. So that means, let's see here, how about -2 and -3? Right? And so that's how I'm splitting up the 5. 2x squared minus 2x minus 3x plus 3 equals 0. We'll split it between the front and the back. 2x is my common factor in the front. And if I pull a 2x out of here, that leaves me with a x minus 1. And then over here, -3 is my common factor. And if I pull out a -3, I also get an x minus 1. And so let's see here. X minus 1 is now my common factor. And that leaves 2x minus 3 equals 0. And notice now we have two things multiplied to give us 0, which means that either x minus 1 equals 0 or 2x minus 3 equals 0. And here with x minus 1, if I just add 1 over, I get x is equal to 1. On this side, if I add the 3 over, I get 2x is equal to 3, and then divide by 2 gives me x is equal to 3/2. And so we end up with these two solutions to our equation. All right, now we have a few more examples, and I'm going to put that into the next video. And so I'm going to go ahead and stop this here, and I'll see you guys on the next video.